We know already the daytime warming. Now we'll be talking about the nighttime coolings. We know that the nights are typically much colder than the days. Nights are cooler, because as the afternoon sun lower over time of the day, the energy is spread over the large area, which reduce the heat available to warm the ground. Both the ground and the air above cool by radiating infrared energy, their process called radiational cooling. So what is radiational cooling? Radiational cooling is the radiating infrared energy from the ground, and through that process, actually air is being cooled. The ground being much better radiator than the air, because air is a such poor heat conductor. Well, the shortly after the sunset, the Earth's surface is slightly colder than the air exactly above it, directly above it. The surface air transfers some energy to the ground by conduction. We know the conduction, which the ground is quickly then radiate away. As the night progresses, the ground and the air in contact with it continue to cool more rapidly than the air a few meter higher up, higher up the ground. The warmer upper air does transfer some heat downward, but the process is slow due to the air's poor thermal conductivity. Therefore, by late night or early morning, the coldest air is found next to the ground, attached to the ground, with slightly warmer air exactly directly above it. This measures increase in the air temperature just above the ground is known as radiational inversion. So radiation inversion because it formed mainly through radiational cooling of the surface. So since radiational inversion occur on the most clear and most calm night, they are also called nocturnal inversion. So now a strong radiation inversion will occur when the air near the ground is much colder than the air higher up. Ideal condition for a strong inversion exist when the air is calm, the night is long, and the air is fairly dry, and also sky is cloud free. So let's look at this in details. A windless night is essential for a strong radiation inversion because a stiff breeze tends to mix the colder air at the surface with the warmer air exactly above it. This mixing, along with the cooling of the warmer air as it comes in contact with the cold ground, cause a vertical temperature profile that is almost isothermal. Isothermal means the same constant temperature. This almost isothermal in a layer several meters thick. In that absence of wind, the cooler, more dense surface air does not actually readily mix with the warmer air, less dense above. So the inversion is more strongly developed at that situation that just described. A long night also contributes to a strong inversion. So strong inversion need a long night. Generally, the longer the night, the longer the time of the radiational cooling, and the better are the chances that the air near the ground will be much colder than the air above. Consequently, winter night provides the best condition for a strong radiation inversion. Other factors will be considered equal. Finally, the radiation inversion are more likely with a clear sky and dry air. Under these conditions, the ground is able to radiate its energy to outer space and thereby cool it rapidly. With cloudy weather and the moist air, the much of the outgoing infrared radiation is absorbed and actually radiate back to the surface, and that actually retard the rate of surface cooling due to the excess energy is radiating back to the surface. Also, the humid night condensation in the form of fog or dew will release latent heat. So we know that when latent heat released from a body to the environment become cool. No, sorry. This when latent heat actually release, that's the air will be warming. Sorry for that. So the radiation inversion can occur on any night, but during long winter night when the air is not moving anywhere, stand still, cloud free, and relatively dry, this inversion situation can be strong and can be deep. On a winter night in the mid latitude, this is a common expression with the below freezing temperature near the ground you will see. So far we have understanding of the nighttime cooling. Those are the important things. So I would say you would pause my video and gather some information, and I will put some question for the quiz and also for the exam. So best of luck. Thank you.